Hi everyone. James, Usman, can you hear me okay?
Yep, I can hear you, Riley.
Yes, your voice is all clear.
Thanks, Usman. Thank you. Hi everyone, welcome. Thank you very much for joining today's live webinar. I hope you are all well. My name is Riley and I assist in coordinating our various free webinars we hold every month. And those are posted on our events page on our website if you want to check those out. So in today's session, we'll be providing you with an insight into EIT's online labs. So the purpose of this webinar today is to provide those of you who may be new to us or have shown some interest in our courses previously. So to provide you with a deeper look into the practical side of learning if you study with us. So our presenters for today are James Theodosides, Dr. Harrison Palmer, and Mohammed Usman Arif. And they will be presenting most of the content for us today. We would like to keep these webinars as interactive as possible. So please use the chat box if you have any questions or thoughts you'd like to share during the session. I will be active in the chat box for most of the webinar, so I can answer any non-academic questions for you. These webinars are recorded and you will receive a copy of the PDF slides and the link to the recording in an email within the next 2 business days. So for the agenda today, I'll just be introducing the presenters for this session. I'll briefly outline just a few facts about EIT and some information about us. And then we'll be going through our remote labs, introducing those and also showing an in-depth demonstration of those. Then we'll be covering hands-on workshops and work integrated learning that are applicable to some of our programs. And then we'll be finishing off with a Q&A session, and we'll try and answer any questions for you while we're live. So I'll just move on to introducing our presenters for today. So James, he's a project engineer and he's been working with EIT for some time now in research, development and management of EIT's practical labs and workshops for both online and on-campus students. Dr. Harrison is currently EIT's laboratory manager and coordinator, and he has a master's degree in chemical engineering from RMIT and a PhD in chemical engineering from Curtin. And Mohammed Usman is a automation engineer, and he's been working for EIT since 2020, and he's been supporting the lab development and practical components of EIT's higher education programs. And he's also completed his master's in industrial automation and bachelor's in electrical engineering. And just to provide all of you with a quick overview of EIT, so what makes us unique as a provider is our focus on engineering. We are engineering specialists, so we only offer courses in engineering, and we provide courses such as short professional development courses that we call professional certificates. We also have vocational courses such as diplomas and advanced diplomas, and we're also highly involved in the higher education sector. So we do offer undergraduate and graduate certificates, as well as bachelor's, master's, and recently a Doctor of Engineering. And for our higher education programs, we do offer online and on-campus options. So our programs are regularly updated to stay relevant with the industry. So to ensure a high-quality engineering learning experience, we update our courses regularly for our students. We also have many courses that are accredited internationally. All of our courses are accredited with the Australian government, but we do have programs that are also accredited with Engineers Australia and some of the international engineering accords. We also have industry experienced lecturers. So what we mean by that is that our lecturers are not only involved in academia, but they've also come from industry where they've had practical experience and knowledge that they are able to transfer to our students to ensure a better learning experience. And our unique delivery model includes our lecturers, which are sourced from all over the world, as well as live and interactive webinars, almost like what we're doing today, and our dedicated learning support, in which every student has contact with a learning support officer that supports them throughout their studies, and also our technologies such as our hands-on workshops, remote labs, and simulation software that we will be covering today. So I'll just go to the next slide, and I believe I'll hand over to you now, James. Thank you very much.
Thank you, Riley. Okay, so welcome all, and my name is Hari Singh. I am a lab manager and coordinator at EIT. So I'll be giving you a brief overview of our remote and virtual labs. So we have tailored our programs where students are required to complete practical exercises using combinations of remote and virtual laboratories. And all of these virtual laboratories have an exhaustive list of simulation software to match the learning outcome of equivalent industrial exposure. Moreover, to all the simulation software we have on our remote labs, our students have equivalent hands-on exposure of physical equipment on our remote and virtual laboratories that will be provided with the robust user interface connected to the physical equipment via sensors and PLCs. This means our online students are not missing out on hands-on practical experience, and that's what we always aim for. On the other hand, we also provide practical exposures for our on-campus students with workshops, hand-on workshops, and work integrated learning via internship in relevant industries. So overall, hands-on exercise using simulation software, remote laboratories, practical-based assignments, and interactive discussion groups, our students are able to grasp new knowledge and successfully apply that particular knowledge in the real world. Each hosted engineering software and hardware. So we host that engineering software and hardware on our remote and virtual labs, and that is controlled in real time. So basically, it is simple as logging in and selecting an available lab at particular time slot and use that for your hands-on experience. At EIT, we are focusing on providing practical hands-on experience to our students, whether they are studying online or on campus. So keeping this aim in mind, we have developed our state-of-art remote and virtual laboratory infrastructure at EIT. So let's just try to understand the setup of our remote and virtual laboratories. So we have our remote labs located in different locations, such as like in WA, Western Australia, in South Africa, and in UK, where the local lab server is connected with industrial automation equipment. So this is our local lab server, which is connected to industrial automation equipment, and our students are able to perform experiments on that equipment remotely. There are traditional laboratory with flexibility to use it remotely in real time, as I mentioned before as well. So as you can see, we have virtual labs located everywhere. This computer are running with various software in various disciplines such as mechanical, civil, electrical, and industrial automation software. So we are representing current trends in industries around the world through those software. We are also running multidisciplinary software which can be used standalone or in conjunction with other software. So our students are provided with robust user interface and round-the-clock availability of these remote labs. As mentioned previously, that our remote labs are connected with specialized equipment with appropriate safety mechanism in place. So EIT students are receiving this experience without any geographical barriers, and our global teams are always available for students in case they require any help. We can now cover a few of the examples of our remote labs which are available on our Electromeet platform. So here you can see the AC motor control with VFD, variable frequency drive, control via PLC on our remote lab. Our students can develop the understanding of various applications of that particular variable frequency drive and PLC, and they can correlate that and experience with the industrial experience. Student can also be able to perform experiments on how the speed of motor is controlled at different loads by adjusting the frequency and the voltage remotely. In the second example of our remote lab, we have practical exercise on 4-pole squirrel cage induction motor, and our student can perform the measurement of phase voltage and neutral current remotely via user interface shown in this particular slide. In this particular slide and few more slides, I will just go over the step-by-step process of our Electromeet platform, and later on this webinar, James will also demonstrate this Electromeet platform as well as few more examples on our remote lab. So if you go to our labs.electromeet.com and if you log in via EIT credentials, you can see various labs on the platform and you will be able to book the slots. You can see the calendar icon here, so you can be able to book the slot. And the computer icon turns green when you have the slots available and you have the bookings available on our remote lab. Once you log into that computer, you can see various softwares and you can click on remote relevant software, start working on that particular software as per your requirement or as per the assessment requirement. Here we can see one of the example of advanced distillation exercise in Simtronic, where you can see you can simulate single equipment or you can simulate the entire plant. So you can begin to operate your simulation. You can be able to, obviously after the simulation, you can be able to extract the profitability data, or you can be able to analyze the critical safety performance of your simulation or critical safety performance of the equipment itself. Now you can also go ahead and this particular example that we are covering here is also connected to the VF, Virtual Field Operator program, which is also provided by Simtronic, and which enables you as a user to virtually walk around and interact with your process plant that you have simulated. So basically, if you have simulated distillation column and few other equipment, you can virtually walk through those equipment in the plant. So once you go through the plant, it's a virtual walk around the plant, and you can ensure that the plant and equipment is operating efficiently and safely. You can read that pressures and all the conditions throughout the plant as well. Thank you for listening, guys. And now I'm passing on to James, and he will go over our student experience and go over the remote lab examples with the demonstration. Thanks, James.
Thanks, Harry Singh. Hello, everybody. Before we get into a preview of the labs, are you actually using the interface in real time? I'll be speaking over a video demonstrating a bunch of different software and hardware that we provide. Thought I'd share a few words from our student ambassador last year in 2020 and her experience with EIT. This is Mildred, and I'll quickly share a video. I'll let her speak for herself.
My name is Mildred Nanono. I'm from Uganda. With EIT, I did a Master of Engineering in Industrial Automation. EIT understands that people are actually very busy. People can get to work and not have a life. So they create an environment that enables you to balance work and then study at the same time. EIT's use of state-of-the-art technology was very, very instrumental and very beneficial. The simulations felt real. It felt like I was physically in the lab. Since studying with EIT, I am more confident than I was before I did the master's. To all students out there, you don't know what you're missing out on, because online class is as good as being on class. I'm very, very proud of the decision, and I hope people out there can get inspired by my experience.
Okay, thank you to Mildred for that lovely promotion, and leads us well into the topic. So what is the very purpose of doing these online laboratories? So why do they exist in the first place? To meet certain student demands. EIT started its foray into the advanced diplomas, bachelor's and master's above, as predominantly online delivery modes. In fact, on campus for bachelor's and master's came much later, as it does not come for the advanced diplomas, based on the types of students that like to undertake that course. So I'll be speaking over this video about the remote labs now. So this is the platform, as Harry Singh mentioned. It's called Electromeet, and it has gone through a long ongoing development phase, and it will continue to do so. Because it's important to constantly be, adapting to the time, the best infrastructure, the best student experience that we can offer. So this is the landing page. All advanced diplomas, bachelors and masters make use of the labs at one point or another during the program. Some more than others, and the various labs serve different purposes. So this is the interface. Why do we have these remote labs? Well, 24/7 access, a specialist software that we can provide to students, often very expensive industrial, down to teaching software. And we'll have some examples of each, because each fill an important role in the course. The labs serve to both provide a more interactive experience to verify learning in the students, and to replicate real-world design processes and simulation. So here we have our list of labs and the connection status for each. We have a distributed architecture. We've got labs in Australia, the UK, South Africa, and the reason being to reduce the latency, so students can connect to a lab more local to them, because it physically has to make a connection one-to-one through a proxy server to a dedicated lab computer. So one student using one lab computer at a time, and so we have duplicates to avoid congestion in the system. So these are real physical computers in real space, and often we launch some virtual labs based on ad hoc projects and sessions, like for certain companies like Rolls-Royce or BHP. This is a list of the software and hardware on each lab. One of the features we're working on doing is integrating these directly through to the learning management system. So we host various instructions and files and downloads for each of these software packages, and we want to make a more integrated system. So currently, to connect to the remote labs as a student, you'll be on the learning management system that has your course materials and assessments, you'll click out to the labs and it will throw you onto this page, log you in automatically as an EIT student, at which point you can book a session whenever you like, when it's free. This is the calendar button you use to connect to and book their session, and you can do file transfer onto and off of the lab computer based on downloading assignments, uploading files for. The lab computers, to keep them stable, we do a hard refresh every week during a certain blotted out time, which reverts the lab computer to a state that we know is working and stable, because students will move files around. You know, these are basically Windows computers, right? A lot can go wrong, and this helps us support. And we do have a dedicated support team behind the scenes work to keep this infrastructure going, because license need renewing, things need destroying, computers need updating, images need to be taken. So we host all our online software and hardware documentation via that button there. It can be downloaded anytime when you connect it to the lab computer. And so that's basically the overview of the Electromeet interface. Search details, if you need to fast filter, the software can be, there's tons on the labs and a lot of duplicates. You can just type in the name in that field highlighted there as a quick search, and it will filter based on what software you need. In practice during the course, your assessments will tell you exactly what software to use. It won't specify what lab, because it will be duplicated over many labs, many regions, and some software you can even download yourself, but this ensures a standard technological baseline that we can control. So we can host computers of a specification needed to run certain software, be it high-spec software for simulations and rendering, that kind of thing, interacting with hardware, down to low-spec basic ones, and we'll give examples of each coming up. So choosing a lab computer, so what does it do? You find what software, you find what labs it's on, you want to connect to that. And so we'll now show you how the booking system works. It's on the Book and Access tab, which you should be thrown to by default. The Home tab contains PDF instructions for the lab. So on to making a booking with the system. Any questions as you go, please throw them in chat. I'm keeping one eye on the schedule there. Yeah, about this specifically, if you've got any big questions about how it all fits in towards the end, please save those for the end. Things like about courses and quals, or type them as you go. And Riley and the other instructors will try and answer you live. We'll do have time at the end for Q&A. So this is the calendar system. Once you click the booking icon there, so next to each you'll see a calendar, this pops up. The grey are past booking sessions, the red are future, and it's a moving point time zone. So I booked the current time, which was free. It gave me a green icon, and the lab button goes green, showing that I can in fact connect to it. And so there's a green button next to that, which is also the file sharing system to the lab for the method to get files on and off of the lab as well. So here we are. The first one we're going to show is a what we call a remote lab, because there's hardware attached to it. You could all call these all remote labs if you want, in the sense they are literally remote labs. So civil engineering will refer to, you'll have specific software for the civil engineering course, and then you look up what software that is, and it tells you what lab to go to. But this is this lab specifically hosts multiple software. They all do. This specific one is connected to what we can see over webcams there, PLC traffic lights. And so we've got the ladder logic program. This is Rockwell in this case on the right. And so if we want to, we open the program provided to us, we can run to interface. First, we make a connection with the PLC, and then we switch it on. The program's put into run mode, and we can see it real time ticking through the ladder logic, connecting to the PLC over the local lab network. No, your computer just needs an internet connection, and one of the benefits of the remote labs are the remote lab computers themselves are doing all the brunt of the processing task. Your computer is just streaming a live feed of the screen, and it's scaled to your resolution as well. Effectively, so whatever your computer resolution is, it will blow out to that. But the lab computer itself is doing the hard work. You just need an internet connection to maintain. No video after webinar, that's okay. And so, yeah, we can also pause and edit the program in real time as you would in practice. And this relates to pretty much all our automation courses make use of labs that make use of, memory blocks, editing ladder logic, that kind of thing. This started as part of the advanced diploma and then expanded into a bachelor's in MIA. But these labs are there regardless of whether in assessments or not. And as a student, you can connect to it and explore what's on offer. The software and hardware drives do list full instructions, and they're all available, nothing hidden at the time to a student. simulation. This is another lab computer, and this specific one was developed in concordance for a specific electrical isolation procedure for disconnecting equipment, isolating it so that it can be worked on. And then we start this particular exercise by selecting what equipment as a technician you would take to site in order to complete successfully the isolation procedure. So this is step one. And this is some software we actually developed in-house, the EIT team, to meet specific course requirements. So this is our effectively proprietary software. You can see there I selected the wrong equipment, and so it told me to try again, flagged an error. And so I'm just throwing what exactly I've put in my bag as an electrical technician to conduct according to best practice procedure. This one delivered in the context of a Rolls-Royce course for electrical engineers to the work site. And so now that the correct tools are selected, we depart for the work site and click. Load the simulation, and here we are, front of the electrical cabinet. This is connecting remotely over the lab system as you would use it. Slight latency, but all perfectly usable. We make sure the student experience is good and constantly take into account feedback and launch new labs if we have to. And so this is just conducting the procedure, rotating isolators, flipping the breaker, on the MCB, and then there's a circuit diagram that corresponds to this, which we can look at. And so we've got the instruments that we brought with us to the site. And so now this allows us to virtually conduct the procedure. It is a rough approximation to how we would do it on the site. We haven't got too many helpful tips in this one, just only using the software, not about the procedure itself, because this does form a basis of an assessment in order to assess whether the students understand how to physically do the procedure or not. And so we'll output a score at the end of this and a checklist to make sure the steps have been followed in the correct order. This would be administered in the context of a course where an instructor who has physically conducted this procedure in real life is informing the students, and we'll be assessing them following this up with a layered assessment system. So this is mimicking a real world process. We follow up with a quiz just to verify the understanding of the theory as well. And it's important that the courses do both, not necessarily right away in the sense of a bachelor's where you need to establish a whole bunch of fundamental knowledge first before we get into the real world application. But for a technician, it's important to, they tend to dive into that right away. To some extent. So this is very much technicians. Now we're probing the circuit with our voltage tester. We can see the probes on the screen. We light up red if we hit a live connection, and so we've either tested it wrong or it hasn't been isolated. In this case, we're testing the high side of the circuit, which is still live to earth or neutral. And so we can see that the procedure was wrong and the checklist marked us wrong as such. And so we repeat the procedure until we get it right, and exit the simulation when done. So that's an example of an electrical technician simulation. So what we've got next, this is a lab we developed as a proof of concept. It's another little proprietary one. We hooked up a U-arm and controlling it, wrote a little Python, using the Python API, wrote a little script in order to give us some live real-time control. And so this is something we're looking to develop and possibly put into our mechatronics advanced diploma. And gives us real time control over the robot, lets us output, the end effector position. If we were to expand this into a direct assessment, we would do something like, based on the dimensions of the robot and the control and the angles and what you can see, what you can verify based on control and experimentation, you would calculate, for example, the inverse kinematics of that specific robot. This is another lab that's connected to hardware. This is in our electrical courses, bachelor's. And so effectively what we've got, the circuit will pop up on screen. That's what the hardware is. It's both a signal generator and an oscilloscope combined, and we've got that connected to a little RLC circuit that's sitting on top of it in a bag to keep out some dust intrusion. And what we've got the digital instruments that connect to the physical real ones. So we've got a real-time generator and a real-time probes, and now we're controlling the signal going through this resistor inductor capacitor circuit. Now we can see the output of the scope in real time, and we can adjust the input frequencies and the scales as we would a real oscilloscope. So the advantage of working with this hardware on the remote labs, we're trying to approximate it as close as possible to basically real life. And so using a real circuit has certain advantages, but not always necessarily the case. If the lesson is to teach a certain aspect of the theory, sometimes a simulation will suffice. Depends on what the lesson is, and the lesson is derived by the learning outcomes found in either the training and assessment matrix or the unit outline or module outline of a given unit in a given course. And so we picked the right tool for the right job. This is a couple tanks one. This is a hardware experiment, couple tanks, classic process control exercise to begin. We're using a Raspberry Pi here to host CodeSys software, a good quick and easy introduction to some ladder logic standard software used in PLC programming. And we also have established a proper safety relay latching system to control the overflow, underflow sensors and pumps on that tank. And so that was the human machine interface for that shown. This is software from an external company provided. This is Simtronics process control, and it shows the operator interface to a distributed control system for a chemical process plant. So Harry's seen the slides before, and this is a real world imitation of kind of mimic screen for that an operator would see in the process site. We've had the instructed person who wrote our instructions for this was based in the Middle East, is a process control chemical engineer. And so logging in, you can also load a virtual walkabout of the plant. Now this is more fun gimmicky, but it gives you a good operator view of local instrumentation. And this is in fact connected to that operator system that you've seen before. And so this would appear in select courses in process automation control. And it just gives you, the technician on the ground view of what you'd be seeing in that distributed control system. And it's got some teaching aspects to the system as well. Not bad. Some students can get latencies issues in this aspect of the system, where the control system works well, because you got to move around in 3D. There's certain workarounds based on, we got to work on like kind of the student's minimum expected internet connection capabilities, which does vary quite wildly. But the nice thing about this 3D aspect is this part of the software is open license. The DCS is not, but students can install the 3D model locally on their computer. We provide it in the context of when this is delivered in the course, install that, and then they can point it at our lab computer server hosting the DCS, and it will talk together. So the values, what you're doing to the valves in the distributed control system, and it is programmed with some some scenarios such as generating errors that you're meant to respond to, that can all talk together. Here's a mainstay of university engineering courses, good old MATLAB, and appears in many a thesis project, and it can simulate near anything with its expansions. It's got Simulink and Simscape, which lets you program real world systems simulation. It can talk to hardware as well. A good internet speed, good question. At least 1.5 meg connection, like minimum. ADSL speeds to up is good, but ping will be your main factor. In latency, the round loop it needs to do to communicate with the lab computer. But our South African students connect to Perth labs quite okay and not need to rely just on the South African labs themselves. So that was a MATLAB demonstration showing power machines, just running some virtual AC/DC plant setup. This is some basic circuit sim, very appropriate for first year or introduction to circuits, where you can set up some op amps, design your circuit, and then you can output some virtual oscilloscopes. So no hardware here, just software, and this software is so low spec that we can run it on an Amazon server without any trouble, and students can even download it themselves if they want. But if their computer's not up to scratch or they don't feel like installing or whatnot, they can access this remotely via the remote lab system. And we provide a whole bunch of example files with these circuits pre-built and videos based in that software and hardware recording file that was linked right at the start, just on top of all the remote labs. So that lists all the software that's on the labs as well. So that's LT Spice. Now another type of software, teaching, very much teaching in mind. This is HSTS. So in the classroom, when learning, you might have these physical experiment kits. Well, this software can virtualize those. If you have the physical kit, it can be plugged in and talk to it, but we're not locally there to manipulate it. So we're going to use the virtual tools here and values relating to the actual civil experiment here. It's not an actual bridge, you can build up to that, but first you want to isolate aspects of the lesson like bending moments and reaction forces at joints, and this software can help us do that and just ascertain those concepts and prove them to ourselves with these experimental setups. And so the bending moment diagrams, we can output it. Lots of different software we provide that does this. Things like Bean Boy, you can set up more advanced simulations when you're ready and more comfortable with CAD software in Autodesk and SolidWorks suites. And SolidWorks is one of the softwares coming up that will show you basic CAD program, but here's the output. from the experiment in a text document. And so the assessment might ask, proof of concept, what are your results? What do you think? And then further question you in the assessment on your findings. And it's very important that the assessment tool not only asks you to use software step by step, but has some variation, asking you to change values, asking you to use insight and infer and really ratify and connect the theory and what you're witnessing in following these steps. Because the lesson isn't just follow these steps. The lesson is how does this relate to, real world phenomenon, an understanding of a theory, a challenge of the theory, what can go wrong, what goes right, what the relationship between all the variables that we're seeing. So a core aspect of knowledge bases as engineers. And so this is an example of an in-tutorial demonstration. This is a instructor, a lecturer in this case, in higher education, giving an example using ANSYS software. Now, ANSYS is great. It's finite element analysis software. It's used to simulate computer model structures, electronics, machine components, fluid flow, temperature distribution, that kind of thing. It's a good one to upskill because industry does use this quite a bit, and it is a very powerful tool for final years projects and theses and whatnot. So you can design heat sinks and heat exchangers and whatnot. A couple of master's students are supervised years past in group projects. We use this for, well, I use the uni for, vehicle aerodynamics, how the aerofoils, aero of a vehicle perform. In turning a corner versus head-on, or the wind dynamics, and we can also use it for the heat distribution through an automated greenhouse. That was the one I was supervising. So interesting project, very versatile, and you can see the FEA analysis here in simulation. And this informs your design practice. You're doing simulation before you bother procuring and machining and tooling and all that stuff. This gives you a good basis of estimate. And finally, we'll wrap up with good old SolidWorks, staple of many a mechanical engineering course. After this, so just finishing, skip ahead to there's our SolidWorks example. So we're making this little widget, so this little machined part here, and CAD program, classic for precision mechanical engineering parts. Make sure you get the orientation relationships right, and then you can output this. And the outputs of SolidWorks model are very much something that in the real world you'd itemize, put into your inventory management system, send it off to the manufacturer for machining or tooling, come back with comments, verify that the parts fit together. A good important one that often goes overlooked till the real world is make sure it's actually manufacturable by physical means and hands. It's like, oh, that part works well in design, but can you actually build the thing? That's another question. But yeah, SolidWorks steps you through that, and it is industry grade, software. This is seen in hardware sectors all around. So register students to simulate things in offline mode. No, this is all purely using the remote lab system. So you got to log into the labs to use it. If you're a student, some companies do give you a discount, but the advantage of the remote lab system is that you don't need to buy it. You log in and you've got kind of full access to it whenever there's a 24/7, as long as you book your session. Insofar as booking, another note is you can book 4 concurrent hours at a time, and as each hour clocks off, you can book another hour and add it into your student account. That's the current rule of thumb we've got. I think PhD students get a little more. But that's it for the remote lab demo and some of the various software packages that we offer in our courses. Now throw back to the main presentation. And over to Harrison for a comment on the hands-on workshops and the work integrated learning. Thank you all.
Thank you, James. So I'll quickly provide overview of hands-on workshop, and then Usman will go over work integrated learning. So we have basically biannual hands-on workshop for our on-campus bachelor's and master students. This is running 4 weeks continuously. So you can see on the table that we are having 4 weeks workshop. Week 1 will be the measurement science workshop it's a common for all discipline. Week 2 will be mechanics and assembly workshop for our bachelor's in civil and structural, and also for mechanical engineering bachelor's. We also have a power control workshop on week 2 for students in electrical and industrial automation. In week 3, we are having a construction and surveying workshop for civil and structural students. transmission and protection workshop for our electrical engineering students, and process plant workshop for mechanical and industrial automation students. In week 4, we are running various industrial design workshops and professional practice workshops. Our hands-on workshop includes various experiments running on PLC training kits and lift simulators for industrial automation students, and our civil engineering students, as you can see on the photographs, that they have evaluated consistency of concrete with various slump cone testing during the workshop. We also provide practical exposures for our on-campus students with work integrated learning via an internship in relevant industry. So now Usman will discuss more on this. So I'll pass on to him, and thank you, Usman.
Thank you, Dr. Harrison. Hello, everyone, and thanks for joining us today for this webinar. So I'm here to talk about work integrated learning. During my talk today, I will explain to you guys that what work integrated learning is, and it does include internships and hands-on workshops, and why they are important to you or the students who want to pursue a career as engineers. So work integrated learning, it actually provides students with the opportunity to apply their learning from academic studies to relevant experiences and reciprocate learning back to their studies. So students who actually participate in this work integrated learning are actually, the main focus is that they should be employment ready, and they should fare better in their job research after their graduation, and the transition from school to full-time employment should be smooth. So that's the main focus of work integrated learning. So what is actually work integrated learning? Is an umbrella term for a range of approaches and strategies that integrate theory with the practice of work within a purposefully designed curriculum. So the activities, it includes usually placements, also known as internships. So internships consist of a student performing course-related work while embedded or working with industry or community partners. Secondly, it can be projects which consist of industry or community partners acting as a mentor or a client to students in order to complete a specific task. The other form can be field trips, also known as study tours, which involve students working with industry or community partners, undertaking site visits and data gathering inside the field. So now I'm going to explain that why industrial or hands-on experience is so much important during your studies. So first of all, it enables the student to gain first-hand exposure of working in the real world. So next, it can help in practically. So the best way of learning the engineering is to do it practically, and that's another advantage. So industrial experience through work integrated learning also provide an opportunity of trying something new, which is very beneficial for career growth. Another one is it encourages personal development, which is very important for greater understanding of self. And moreover, it encourages industrial experience also provides an opportunity to showcase students' talent, commitment, and value to a prospective employer. And another big advantage is that it adds a valuable experience. So these internships are the perfect way to enhance the CV through relevant experience, which they get through these placements. So currently, students who are actually studying at EIT or who wants to study at EIT, they have to complete 240 hours of work engineering experience to graduate, and this is also required for Engineers Australia accreditation to achieve stage 1 competency elements. There are some 0 credit units needs to be completed with work and hands-on experience, and evidence needs to be provided to graduate from EIT. For bachelors, this is BSc 110 and BSc 210. These are few units that are related to industrial experience, which needs to be completed, and for hands-on workshop BXS 001 to 004, which was already explained by Dr. Harrison. And for master students, they have to complete MXX 001 and MXX 510. So these are the units which actually comprised of these 240 hours of engineering work and hands-on experience. But there's one advantage for the people who are already working in the industry, that they can apply for RPL, recognition of prior learning. So they can give the evidence that they have already completed 240 hours of engineering work. So in this way, the EIT will assess their application, and they don't have to go through this process, and they can easily get the RPL. So the next one is, how EIT is supporting its students in this regard of work integrated learning. So EIT is actually providing an opportunity to apply for the engineering internship scholarship. So we have a scholarship programs over here, which covers the cost of going through an internship placement company, or it can pay a fee to go through an internship placement company to complete the 240 hours of work. Secondly, EIT has collaborated with the Outcome.Life, which is a placement company to provide internship opportunities to on-campus students. And a lot of our students are already working within industry to fulfill their requirements. And third, the EIT is also providing its students the opportunity to attend ongoing conferences hosted by IDC Technologies. So these conferences are very important, and these are actually attended by highly experienced engineers and directors of different engineering companies. So very good exposure to the industry. And next big support EIT is providing, that they are providing free student membership to its students from Engineers Australia. This membership provides the students opportunity to attend Engineer Australia events free of cost. And these events are very good platform for networking and career development. In the last, EIT is also arranging guest lecturers which have vast industrial experience to come on campus and online to interact with students and give an insight of different engineering developments and skills required to become successful engineers in today's market. So this is where EIT is actually supporting its students. So from now, I will hand over to Riley to explain about more insight on studying at EIT.
Thanks, Usman. I really appreciate it. So yeah, as Usman mentioned, I will be just covering potential study at EIT if you're interested in that in the future. So we do believe in a lifelong learning journey, and as I mentioned at the start of the webinar, we specialize in engineering. So as you can see from the graphic, we offer courses from professional certificates. Those are non-accredited professional development courses, but we also offer advanced diplomas all the way up to a doctorate of engineering. So depending on your personal circumstances and how you meet the entry requirements of our programs, we do offer courses for everyone. And you can see on the graphic as well what kind of study pathways you could take in order to upskill and meet the requirements of higher programs. And then for our delivery, so we do have live and interactive tutorials for all of our courses. If you're studying online, you'll have similar webinars, regular webinars, just like what we're doing today, and a international pool of expert lecturers, dedicated learning support, and all of our practical components of our courses that we ran over today. And for student support, we have learning support officers in our VET and higher education programs, and they will be your go-to contact person throughout your studies. If you have any non-academic related queries, they will be able to help you with that in terms of accessing resources, classes, helping you with assessment extensions if need be. But they are your guide from basically enrollment to graduation. And obviously you also have your lecturers to contact as well for any academic queries. I'd just like to mention as well, we have a couple of technical topic webinars coming up. So if you would like to attend those, we have a industrial data communications technical topic webinar tomorrow actually, if you're interested in that. And we also have in a couple of weeks time a civil engineering webinar that you can attend. And as mentioned earlier, all of these webinars that we post on our events page on our website are free to register for. We have a range of webinars that you can register for, including these technical topic webinars, which we do provide a free certificate of attendance for as well. So be sure to check that out if you have some time. And now we'll just move on to a Q&A session to finish off. Yeah, I'd just like to ask everyone if they have any questions as of now, or if they asked a question previously that was unanswered, we'll all try and answer any questions that come through while we're still live. Yeah, Usman, James, and Harrison, if any questions come through from the chat, please feel free to take them if you're comfortable with them. And while we wait for questions to come through, I'll just put our contact details as well up on the slide there. Thanks, Harrison. If anyone does have any questions, please feel free to use the chat box, and one of us will answer your question while we're live. Thank you.
So it's Usman here again, so I'm going to answer for Charles. So for applying for scholarship for work integrated learning with EIT, the application needs to be submitted 6 weeks before the start of term for assessment, and it's compulsory for graduation. If someone doesn't have RPL, then still they have to do these 240 hours of work in the industry. And for that, if they don't have the scholarship, then it's almost costing $1,800 here in Perth in Australia. So that's the cost right now going on in Australia for placement, and it's a guaranteed placement, and it's going to be almost 6 weeks.
Harrison, would you be able to take that? Oh, thanks, James. Please feel free to ask any more questions in the chat box if you have any. Otherwise, if you do need to go, or please feel free to leave. The webinar has now finished, but we will all stay on in case there are any questions. So thank you for your time today, and enjoy the rest of your day wherever you are. And yeah, as mentioned, we'll still try and answer any more questions that come through. Thank you.
Thank you for attending.
Ola Deji. Our courses at EIT are scheduled. We don't offer any self-paced courses. However, if you are looking at studying one of our higher education programs, we do usually offer to study part-time. However, none of our courses at this stage are self-paced, so you will have regular webinars to attend in classes. So I hope that addresses your question. Frank, we do have a range of partial scholarships that you can view on our website. I'll just post the link in the chat box for you. So you just have to look at the specific scholarship page to view eligibility requirements, as we have different scholarships for different courses. Hi, Ola Deji. We do have a range of internationally recognized courses with professional bodies. I'm just going to provide a link for you in the chat box to our accreditation, and you can view all of our programs that have international recognition, and it will outline what professional bodies recognize our courses. To everyone still in the session, I believe that is all we have time for today. So thank you very much for joining. You will be sent the PDF slides and the recording of this webinar within the next 2 business days. I hope you all enjoyed it, and thanks to James, Usman and Harrison for a great presentation, and see you all next time. Thank you.
Thanks again. Oh, thanks Riley as well. That was good.
Guys.
Thank you. Have a good day.